Hello, Miss Walsh here. Okay, so what we're going to do today is more quadratics, woohoo, and we're going to work backwards. So we're going to be given a graph, and from there we are going to have to determine its equation, woohoo. So you'll remember that we have three forms for a quadratic equation. We have the vertex form, where we learned that h and k is the vertex. We've got the standard form, where these are parameters, c being the y-intercept. And we have the x-intercept form, where the alpha and the beta here are our x-intercepts. So when you get a graph, you will get some information about it, and you have to decide which form is best for you to use. So for example, if you try to start with the vertex form, right? Well, you don't know what the vertex here is. The standard form, not so useful for our purposes. You can use it, but never mind. But we do have the x-intercepts that are absolutely clear. And so what we're going to do is we're going to start with the intercept form. Okay, that's going to be our friend for this question. So we have the A, which always determines if it looks up or down, and we're going to write out our intercept form, and we're going to substitute in the x-intercepts. Remember, the negatives means that the signs do have to be switched. So we're going to have x plus 1 and x minus 2. Okay, you now have three unknowns, an x, y, and a. The process from here on is always the same, and that is to take a point on the curve. Now, we don't know exactly what this is or what this is. I could take this point, for example, so 1, 6, or I could take 0, 6. The y-intercept is always nice and easy, so I'll just take 1, 6. Both of these should yield the same answer. So then we're just going to put that point into the x's and the y's. So we have the 1, and then we have the 6. I'm just trying to color code a bit. So we have a, and then we have 1 plus 1, and then 1 minus 2. And we're solving for a now, okay? So this is going to be 2, and this is going to be minus 1, and so 2, so this is minus 2a, and so a is negative 3. Notice the good news that we got a negative a because the parabola is facing downwards, so the a value must be negative. Okay, so we have our equation now. So x plus 1, x minus 2. Now, if you wanted it in standard form, you could just quickly expand. So let's just do that. So I'm going to FOIL this first. And people always ask, well, what should you do? Does the negative 3 go for both terms? It doesn't. It just goes in once. So I like to expand the two binomials first. So we're going to have x squared. This is going to be minus 2 plus 1. So minus x minus 2. And now just work the minus 3 through. And there we go. That's the equation. Okay, let's do the one on the right here. And again, remember, the first task is to pick an appropriate form. So here we are given the vertex. We can see that the vertex here is 3, 4. And once you have the vertex, then this is good news. Just grab the vertex form and away you go. All right. So x minus h plus k. Remember to switch the sign of the x value only. Plus 4. And now it's the same approach. You need a point, and then you can solve for a. Let's grab this point. So 2 and 6 is a point. 4 and 6 can be a point. and you can do it with 4 and see that you'll get the same answer. Okay, so I'm going to put the 2 here, and I'm going to put the 6 here. All right, and again, pause, finish it on your own if you'd like. This is going to be minus 1 squared plus 4. Remember to do the exponents first, so we're first going to square it. And so we have 1a plus 4, and so therefore a here is going to be 2, right? Take 4 off. Notice the a is positive. Again, this is good news because this parabola is facing upwards. And so our final equation is then 2 is x minus 3 squared plus 4. There's no need to expand it. If you wanted it in standard form, you can write this out twice, FOIL it out, and the rest of it, but vertex is actually the most useful for graphing. Okay, so it's absolutely fine to leave it like this. The two most commonly that you see are in the standard form and in the vertex form. The intercept form is a little bit more rare, but it has its use for graphing as well. Okay, so that's writing equations from a graph. Ciao, ciao.